Okay, so now we will talk about the atomic structure and how it relates to the shape of the periodic table. So if you remember, we said that the electronic structure is first divided into energy levels, and these energy levels are split into subshells, and each subshell is composed of orbitals with different shapes, and each orbital is composed of two or can hold two electrons. Each one of them has a spin rotation in a specific direction. And then we mentioned before that the subshells are filled by this sequence 1s, 2s, 2p, 3s, 3p, and we mentioned that 4s is filled before 3d, and the same for 5s is filled before 4d, and 6s is filled before 4f and 5d, and so on. And now we can say that if we wanna like put a definition for the periodic table, it is a table that arranges the chemical elements according to the increase of the atomic numbers, and it the way it looks like this is because each row includes elements with unfilled or just filled electrons in the same energy level. So that's why it's different. We find that energy levels are filled with different number of electrons, and that we have the elements with similar atomic structures are in the same row. And that's why the again we mentioned that this is how the electrons are filled. We have the K energy level filled by 2 electrons, L is filled by 8, M is filled by 8, and then N is filled by 18, O is filled by 18, and so on. This is based on this, and we assume that, or we can tell that the energy level starts to fill when the S subshell starts to, S orbital starts to fill. So we have here one S's for the first, and then 2S, 2P, this is 2 and 6, this is 8, which is here. And then we have 3S and 3P, this is 8, and then 4S, 3D, 4P, this is 18, and so on. And that's why the periodic table looks like this. If you take a look at it, you will find that this is filling only 2 electrons. This is 1 electron, this is 2 electrons, and this represents the S subshell. The S orbital. And then you'll find that this part of the periodic table is composed of 6 columns, which means that this represents the P orbital. And again, if you look at the first row, it is just 2 elements, which fills two electrons, which is the first energy level. The second energy level and the third energy level, we have 2 and 6, we have 8. The third energy level, when we start to, the fourth energy level, when we start to fill the 4s, we have 4s1, 4s2, and then you would find that we are filling the 3D before filling the 4p, and that's why this represents the d orbital, and finally this represents the f orbital. Again, relate this to this. It's 2a, 18, 18, 32, 32. You find that this 2, 8, 8, 18, 18, 32, 32. And this is, we have the F is filled with 14 elements. And this is why the periodic table looks like this. So it kind of answers some questions that people might have. Why do the elements look, or the periodic table looks like this? The way the periodic table is drawn is as we see here. This is how we usually see the periodic table, and the way it's put like this is because this shape this shape is very, very big, and if you're trying to look at some details, it will be difficult. You have to put it in the very small fonts so that you can put everything in one shape. But to make it easy to see, we have this what we call the lanthanide and actinide series. They're put down here instead of having them put inside the table, and that's how the periodic table is put. We will talk in more details about the properties of elements and the periodicity, but just I want to highlight something that we just mentioned or just mentioned before. If you look at this, you'd see that it's filling 2s1, this is filling 3s1, 4s1, 5s1, 6s1, 7s1. So this column is filling one I'm sorry, it's filling the same orbital or the same electron in the same orbital. Um, I mean, the same orbital name. And here is filling the orbital s, H2s, 3s, 3, 4s, 5s till you reach 7s. Again, the same thing. Here you'll find that it's filling 3d2, 4d2, 5d2, 6d2. Again, here 3d8, 4d. You would find some discrepancies here, especially in the transition elements. But for instance, this you'd find 3d5, 4d5, 5d5, and 6d5. We'll talk about these discrepancies in kind of next one or two videos. And here again you would find that it's filling 2p3, 3p3, 4p3, 5p3, 6p3, 7p3. So it's repeating everything as we see. And here it's if you look at the same row, it's 4s1, 4s2, and then 3d1, 3d2, 3d3, and so on till you reach the all of them are filled, the 3d10, 4s2, and 4p6. And this is how everything looks like. Again, you would see that there are some regions here that are kind of grayish and some are whitish. And again, we will talk about these different colored elements because the way they are filled is not as expected, and we'll talk about this later. Again, we said that as you go down, you're increasing the period, so you're opening a new energy level. The same number of electrons is in the last energy level, and as you go to the right, you are increasing the group number, so you're adding one more electron in the outermost energy level. The next video will talk about the periodicity of elements and how the properties of elements are or change as you go to the right or down. So this is what we're gonna talk in the next video, inshallah. So I'll see you then. Goodbye.